Arthritis. It is not the genes causes disease. It is the environment that causes disease. Genes are regulated by environment. Signals the genes for the disease. It is the reaction that includes emotions. Emotions send signals to upregulate or deregulate. Genes are getting instructions from environment outside of the cell. Your emotional energy is the key to unlock yourself from the disease. It is possible to send signals to gene ahead of bad environment. Welcome to this in-depth on arthritis, a group of musculoskeletal disorders that significantly impact patient health. Arthritis, a term encompassing more than 100 different types of joint disorders, affects people of all ages, races, and genders worldwide. From the commonly known osteoarthritis to the autoimmune-driven rheumatoid arthritis, the diversity of these conditions contributes to the complexity of managing arthritis effectively. In this course, we will explore the most prevalent types, their unique characteristics, and the impact they have on individuals' daily lives. Understanding arthritis requires a grasp of the fundamental mechanisms underlying joint inflammation. We'll delve into the anatomy of joints, examining how inflammation can disrupt the delicate balance, leading to pain, stiffness, and reduced mobility. By comprehending these underlying processes, you'll gain insights into the symptoms associated with arthritis and the importance of early detection for effective management. As we progress, we'll shift our focus to the diverse treatment options available for arthritis. From traditional pain management strategies to cutting-edge therapies, we'll explore the spectrum of interventions designed to alleviate symptoms and improve overall joint health. Additionally, we'll discuss lifestyle modifications, including exercise routines, various medications, and dietary considerations that play a pivotal role in managing arthritis and enhancing the quality of life for those affected. Understanding arthritis. We kick off our journey by defining arthritis and understanding its classification. Arthritis, derived from the Greek words arthron meaning joint and itis meaning inflammation, is a term encompassing a diverse range of joint disorders characterized by inflammation. It's crucial to recognize that arthritis is not a single disease but a collective term for over 100 conditions affecting joints, leading to pain, swelling, and decreased joint function. Epidemiology and impact. Let's dive into the global prevalence of arthritis, its socioeconomic impact, demographics, risk factors, and the burden it places on healthcare systems. Understanding epidemiology of the disease is crucial to appreciate the scale of this condition and tailor healthcare policies accordingly. Types of arthritis. Arthritis is a broad term encompassing various inflammatory joint disorders, each with its unique characteristics and underlying causes. The classification of arthritis is based on different criteria, including etiology, clinical features, and pathophysiology. Here, we'll explore the two most prevalent types of arthritis and their pathophysiology. Osteoarthritis. Osteoarthritis is the most common form of arthritis and degenerative joint disease that primarily affects the cartilage in the joints. Cartilage is the protective and flexible tissue that covers the ends of bones in a joint, allowing smooth movement. In osteoarthritis, this cartilage gradually wears down over time, leading to pain, stiffness, and reduced joint function. Key features of osteoarthritis. Cartilage degeneration. As mentioned before, the hallmark of osteoarthritis is the breakdown of articular cartilage, the smooth covering at the ends of bones in a joint. Over time, the cartilage becomes thinner and less resilient, losing its ability to absorb shock and provide smooth joint movement. Bone changes. As the cartilage wears away, bones may start to rub against each other, causing pain and further damage. The body responds to this by forming new bone at the joint's edges, attempting to stabilize the joint. These new bony formations are known as osteophytes or bone spurs. Synovial involvement. While traditionally considered a non-inflammatory condition, osteoarthritis does involve mild inflammation in the synovium, the lining of the joint capsule. Synovial inflammation contributes to the release of enzymes that can further degrade cartilage. Commonly affected joints. It is noteworthy that osteoarthritis mainly affects weight-bearing joints like knees and hips. Rheumatoid arthritis. Rheumatoid arthritis is a chronic autoimmune disorder characterized by inflammation of the synovium, the lining of the membranes that surround the joints. It primarily affects the small joints of the hands and feet but can involve other joints and even organs in some cases. Unlike osteoarthritis, which is caused by wear and tear on the joints, rheumatoid arthritis is an autoimmune condition where the immune system mistakenly attacks the body's own tissues, primarily targeting the synovium. Key features of rheumatoid arthritis. Autoimmune origin. RA is an autoimmune disease where the body's immune system, for reasons not entirely understood, mistakenly attacks the synovium. This immune response leads to chronic inflammation, joint damage, and other systemic effects. Symmetrical joint involvement. One of the characteristic features of RA is its symmetrical pattern of joint involvement. If a joint on one side of the body is affected, the corresponding joint on the other side is likely affected as well. The synovial inflammation and proliferation. Chronic inflammation of the synovium leads to the release of pro-inflammatory cytokines, causing swelling, warmth, and pain in the affected joints. Over time, the inflamed synovium can proliferate and form a pannus, an abnormal tissue that invades and damages nearby cartilage and bone. Extraarticular manifestations. Rheumatoid arthritis can have systemic effects, affecting organs and tissues outside of the joints. Common extraarticular manifestations include rheumatoid nodules, subcutaneous lumps, lung involvement, cardiovascular complications, and systemic symptoms like fatigue and fever. Morning stiffness. Individuals with RA often experience prolonged morning stiffness lasting for more than 30 minutes or stiffness after periods of inactivity. Causes of arthritis. Osteoarthritis causes and risk factors. Osteoarthritis's origins lie in a combination of factors, including aging, joint injuries, and genetic predispositions. We'll unravel the intricate web of influences contributing to the onset of OA and discuss associated risk factors. Rheumatoid arthritis causes, beyond genetics. Rheumatoid arthritis, on the other hand, involves a complex interplay of genetic and environmental factors. We'll investigate the intriguing connections between genetics, infections, and environmental elements, seeking a deeper understanding of RA's elusive origins. But that's not all when it comes to rheumatoid arthritis. Research shows that an immune response to a recently discovered species of gut bacteria can also cause rheumatoid arthritis, RA. The results of this study were recently published in the journal Science Translational Medicine. The findings suggest that in some people with rheumatoid arthritis, improper immune responses in the gut may trigger the production of antibodies and T cells that circulate throughout the body and attack the joints, leading to chronic inflammation, which could lead to the development of rheumatoid arthritis. Food habits causing arthritis. While there is no direct evidence that specific food habits cause arthritis, certain dietary and lifestyle factors may contribute to the development or worsening of arthritis symptoms. It's worth noting that arthritis is a complex condition with various causes, including genetic, environmental, and autoimmune factors. However, some dietary habits and lifestyle choices have been associated with an increased risk of arthritis or worsening symptoms. Here are some things to consider. High intake of processed foods, diets rich in processed foods, high in refined sugars, unhealthy fats, and additives may contribute to inflammation. Chronic inflammation is linked to the development and progression of certain types of arthritis. Excessive consumption of red meat. Some studies suggest that a high intake of red meat, particularly processed or grilled meats, may be associated with an increased risk of inflammatory arthritis. Cooking methods that use dry heat and high temperatures can produce advanced glycation end products that may contribute to inflammation. High sugar intake. Diets high in added sugars have been linked to inflammation and may contribute to the development or exacerbation of arthritis symptoms. Unhealthy fats. Saturated fats and trans fats, commonly found in fried foods and certain processed snacks, may promote inflammation and worsen arthritis symptoms. On the other hand, omega-3 fatty acids found in fatty fish can have anti-inflammatory effects. Low antioxidant intake. Antioxidants help protect the body from oxidative stress and inflammation. A diet low in fruits, vegetables, and other antioxidant-rich foods may contribute to inflammation. Excessive alcohol consumption. Heavy alcohol consumption is associated with an increased risk of gout, a type of arthritis caused by the buildup of uric acid crystals in the joints. Gout can lead to painful joint inflammation. Caffeine intake. Some individuals with certain types of arthritis, such as rheumatoid arthritis, may find that excessive caffeine intake can worsen symptoms. However, this can vary between individuals. Food sensitivities. Certain individuals may have specific food sensitivities that can trigger inflammation and worsen arthritis symptoms. Common culprits include gluten and dairy products, although the impact varies from person to person. It's important to note that the way individuals respond to dietary factors can vary, and there is no one-size-fits-all approach. Additionally, maintaining a healthy, balanced diet, staying hydrated, and managing weight can positively contribute to overall joint health. Practice healing energies. Build your practice to write the feelings journals. Stop living by same emotions and repeating the patterns of emotions that are signaling the genes of the environment that you are not good, you are not worthy, you are not living the life you want. Instead, give instructions to yourself that you are living the life you want. Empower your thoughts leveraging adversities. Solving problems for others. Receive compliments for your work. Express gratitude. We have 40 genes that assist in making proteins. We have 100,000 other genes. Mapping human genome, we only express 26,000 genes. Expression of protein is expression of life. Homeostasis is critical of mind, body energy field. If there is imbalance, then body shifts into new state and adapt this imbalanced state as new balanced state. What is gene expression? Let's understand that. Gene expression is the process by which the information encoded in gene is used to direct the assembly of a protein molecule. It is a complex process in which information encoded in a gene is used to produce functional products such as protein that dictates cell function. Gene expression involves processes like splicing, capping, tailing, RNA transport, translation, protein folding, and modification. Genes are upregulated if there is increase in production of protein or RNA, and genes are deregulated if there is decrease in protein. Genes are segments of DNA, which is the genetic material found in the cells of living organisms. Your genes carry instructions that determine various traits and functions in your body, such as eye color, the ability to digest certain foods, or the development of specific diseases. Gene expression is the process by which information encoded in your genes is used to create functional products, typically proteins. To understand gene expression, let's break it down step by step. DNA to RNA, transcription. The first step in gene expression is transcription. In this process, a specific segment of DNA is copied into a molecule called RNA. This RNA molecule is known as messenger RNA or mRNA. Think of this step as creating a working copy of the gene's instructions. RNA to protein, translation. The next step is translation. During translation, the mRNA carries the genetic code to structures called ribosomes in the cell. Ribosomes read the code in groups of 3 nucleotides, called codons. Each codon represents a specific amino acid, the building blocks of proteins. Proteins are large molecules that perform essential functions in the body, such as enzymes for chemical reactions or structural components for cells. Protein formation. The sequence of codons in the mRNA dictates the order in which amino acids are joined together to form a protein. This process continues until the ribosome reaches a specific codon that signals the end of protein synthesis. The newly formed protein then folds into its unique 3-dimensional shape, which determines its function. In summary, gene expression involves the transfer of genetic information from DNA to RNA known as transcription, and then from RNA to proteins known as translation. Proteins play crucial roles in the structure and function of cells, tissues, and organs, influencing various aspects of an organism's characteristics and functions. Changing emotional state allows to select and instruct proteins that instruct genes. Example: with good emotional state, gene expression can be measured. Keep in mind that not all genes are actively expressed all the time. The regulation of gene expression is a highly complex and tightly controlled process that allows cells to respond to their environment and fulfill specific functions in the body. Negative gene expression, often referred to as gene repression, involves the downregulation or inhibition of the activity of specific genes within a cell. Just as positive gene expression promotes the synthesis of proteins, negative gene expression prevents or reduces the production of certain proteins. This regulatory mechanism is crucial for maintaining cellular homeostasis, responding to environmental changes, and controlling various biological processes. Did you know that your epigenetic regulation is the reason to be in healthy state? If you are suffering from any diseases, which means you have deregulated the gene regulation of the DNA. Let us understand the negative gene expression inhibits the initiation of transcription. Negative gene expression can also involve epigenetic modifications, causing DNA to be impaired from its original genetic code. These modifications can make the DNA less accessible for transcription, leading to gene repression. Once the protein degradation occurs, then negative gene expression can also involve the degradation of specific proteins, thus causing the cell repair process to be altered from its natural healing process. Did you know that your cellular response to environmental signals is often part of the cell's response to environmental cues or stressors? For example, certain genes may be repressed to conserve energy or divert cellular resources to cope with stress conditions. Dysregulation of negative gene expression can contribute to various diseases, including cancer and genetic disorders. Genes are encoded by DNA, which can be unregulated and downregulated. Messenger mRNA translated to protein. Each gene has ATG trans site that indicates where transcription should be initiated. Promoter region, specific transcription factors and factors that will help promote transcription will bind to DNA that is to be transcribed to mRNA. Your thinking and feeling creates your persona. When emotional energy, emotional signature is greater than that of the past, then old body is no more same body. Now it carries emotional signature of futures. Ensure emotional signature of present and future is greater than past. Gene upregulation and downregulation refer to changes in the activity or expression level of a gene, influencing the amount of protein produced by that gene. We broke down these concepts for you. Gene upregulation. Upregulation occurs when the activity or expression of a gene increases, leading to an elevated production of its corresponding protein. Think of upregulation like turning up the volume on a radio. When a gene is upregulated, it's like increasing the volume of that gene's activity, resulting in more protein being produced. If a particular gene is involved in the immune response, upregulation of that gene might occur when the body is under attack by pathogens. This increased gene activity leads to the production of more immune-related proteins to help fight off the infection. Gene regulation arises from alteration of structure of gene. Modification to DNA or its packaging may influence which sequence are available for transcription. The amount of upregulation depends on the amount of protein produced by the RNA. You can see the levels of gene control starting from compact DNA to relaxed DNA, then processed mRNA, and finally modified protein. Downregulation. Downregulation is the opposite of upregulation. It occurs when the activity or expression of a gene decreases, leading to a reduced production of its corresponding protein. Think of downregulation like turning down the volume on a radio. When a gene is downregulated, it's like decreasing the volume of that gene's activity, resulting in less protein being produced. In certain conditions, the body may need to conserve energy or slow down specific processes. Downregulation of genes involved in energy-consuming activities could occur, leading to a decrease in the production of proteins related to those activities. In both upregulation and downregulation, these changes are part of the intricate regulatory mechanisms within cells and organisms. Cells have sophisticated control systems to adjust gene expression based on internal and external signals, allowing them to respond to different conditions and maintain balance. These regulatory mechanisms are crucial for the proper functioning of cells and the overall health of an organism. Understanding gene upregulation and downregulation provides insights into how cells adapt to their environment and how changes in gene expression contribute to various physiological processes. Downregulated genes refer to the process in which the activity or expression of a gene is reduced, resulting in a decrease in the production of the corresponding protein or functional RNA. Genes can be regulated in various ways, and downregulation is one mechanism that plays a critical role in cellular processes, development, and maintaining homeostasis. While gene downregulation is a normal and essential part of biological regulation, dysregulation leading to prolonged or excessive downregulation of specific genes can contribute to the development of diseases. Here's how downregulated genes can be associated with diseases. Impaired cellular function. Genes encode instructions for the synthesis of proteins, which are essential for various cellular functions. When a gene is downregulated, it can lead to a reduced production of its corresponding protein, potentially impairing the normal functioning of cells. Regulation of growth and development. Genes involved in the regulation of growth and development are tightly controlled. Downregulation of certain genes during development or tissue maintenance can disrupt normal growth processes and contribute to developmental disorders or abnormalities. Immune system dysfunction. Downregulated genes in the immune system can result in reduced production of immune-related proteins. This impairment may compromise the body's ability to defend against infections, leading to increased susceptibility to diseases. Tumor suppression and cancer. Many genes act as tumor suppressors, regulating cell growth and preventing the formation of cancerous cells. Downregulation of these tumor suppressor genes can contribute to uncontrolled cell division and the development of cancer. Neurological disorders. Downregulated genes in the nervous system can impact neuronal function and communication. This can contribute to the development of neurological disorders, such as Alzheimer's disease, Parkinson's disease, or other neurodegenerative conditions. Metabolic disorders. Genes involved in metabolic pathways, such as those regulating insulin sensitivity or lipid metabolism, can be downregulated, leading to metabolic disorders like diabetes or obesity. Cardiovascular diseases. Downregulated genes in the cardiovascular system may affect the regulation of blood pressure, vascular function, or cholesterol metabolism, contributing to cardiovascular diseases such as hypertension or atherosclerosis. Inflammatory conditions. Genes involved in the regulation of inflammation can be downregulated, leading to dysregulated immune responses and chronic inflammatory conditions. Genetic disorders. Downregulation of specific genes due to mutations or epigenetic changes can result in genetic disorders, affecting various physiological processes. It's important to note that gene regulation is a complex and dynamic process, and the impact of downregulated genes on disease development is often multifactorial. Understanding the role of specific genes and their regulatory mechanisms is crucial for identifying potential therapeutic targets and developing treatments for various diseases. Advances in genomics and molecular biology have significantly contributed to our understanding of gene regulation and its implications for health and disease. Balance meditation. When there is disharmony in the body due to imbalance of the energy centers, then body is knocked out of the homeostasis that is your natural health. Now, let's us do the meditation to balance these energy centers. Let's set the intentions that I as miracle being shifting my consciousness to fully heal my body by repairing the cellular energy. Shift your consciousness from material world to space. As space holds the universal consciousness to allow you to connect to your higher self. Take deep long breath and relax. Slow all your thoughts, move from beta state to theta state where you overcome all conscious thinking. Allow the golden beam of light to connect to your crown chakra, allowing you to be guided for your energy healing with pure intentions. Now purify your energy field by declaring all your energy field is guided from the universal consciousness and all thoughts, feelings, vibrates that you carry from the external world is dropped. You will be tuning to the energy field of cosmic healing this way, you allowing your energy field be upregulated at each cellular level. Let universal energy connects with your energy field and you find the right vibrations to shift from lower vibrations to higher vibrations of healing. Now once you are tuned to right frequency of your higher vibrations, feel the energy field is expanding from your heart chakra to outside your body. Now, let keep this energy expanding across the cosmos. Let you feel the space around you and your consciousness and energy are one and outside the realm of the world. Let this energy field expand across the universe. Feel the higher vibrations are with you through this expansion. Feel good in this energy field. Feel super energized in this energy. Notice that this energy field from the universe to your body is one and you are tuning to your healthy state as you feel that you are the version of good health. Once you lock this energy field in your body, then you have just performed the quantum jump. This new version of you has all cellular healing and all the upregulation of your cell energy is now taking place. Relax. Feel the love in your cells. Relax, feel the energy of healing tuning your health. Feel happy, feel good. Be in this state for a few more moments. Feel that you will keep this energy field activated throughout your day. Feel the vibrations that you carry are of perfect health. Feel the energy field, which is life force energy of your body, is no more down-regulated by external environment and circumstances. There is no stress and only wholeness with the universe exist. Feel this cosmic bliss and feel this cosmic love in each cell. Feel the tingling of the love in the cells. Feel the future of your healthy version is now in you and there is no more disbelief. Even if your body shows some signs as all this pain, stress is impermanent. More you are tuned to higher energy state, more you are tuning to good health, and all false positive signals in your mind are disappearing. Know that by carrying this energy field you will become version of your higher self who is perfectly healthy and living the life of fulfillment. Now, come back into your body, back into your sensations, back in your consciousness with high vibrational energy field as miracle being. Excellent, you did it.